All right, so we're diving deep today. And, those of you who follow the show know we only pick the terribly interesting stuff. Well, this one's a doozy. We're talking Qwen2.5-VL.
Qwen2.5-VL, yep.
And I've got to say, just from kind of skimming through the technical report and the study guide, doing my prep work for this, it's a lot.
Yeah,
But it seems like it's kind of a big deal in the AI world right now.
absolutely.
We're talking AI that can process hours of video footage, pick out tiny details and images. It can even help you operate your computer. This is a pretty wild spot.
It is, it is. It's very exciting.
So thankfully, to help us make sense of all of it, we've got an expert on the show who can decipher these dense technical reports.
I try my best.
So what makes this Qwen 2.5 VL so interesting? What's the big deal here?
Well, we're seeing a lot of different AI models that are sort of reaching a certain level of competence. And what I think is really interesting about Q2.5VL is how it's trying to push past just being competent. It's sort of trying to go from that competent level to how do we really build a foundation that can then allow us to do really amazing things?
So I like that, building a strong foundation.
Yeah.
And, speaking of foundations, the report actually uses this kind of quirky sandwich analogy
Right.
to explain how this all works. Do you break that down for us? The
What's that?
sandwich.
So, think about your classic sandwich cookie. You've got the top and the bottom, and then you've got that middle cream layer.
Yeah.
And a lot of the models right now are kind of focusing on that middle cream layer. They're sort of competent, but they're not amazing. What Qwen 2.5VL is trying to do is it's trying to be both the top and the bottom. It's trying to sort of have that whole sandwich cookie.
Oh, okay. Hey there. Want to share your thoughts on this?
Before the sandwich, can we just wrap up the key points of this work first?
Absolutely happy to do that. Let's get right to the heart of Q.5VL.
Okay, yeah, let's skip the dessert for now and get to the main course.
So really, at its core, this is about advancing multimodal understanding.
Multimodal meaning what exactly?
It means combining vision and language in a much more powerful way. It's designed to really improve fine-grained visual perception.
Fine-grained as in really, really detailed.
Exactly. Recognizing even the tiniest things and also improving reasoning.
So not just seeing, but understanding.
Exactly. And that, agent functionality, making it more useful in real-world applications.
Okay, so it's about seeing, understanding, and doing.
Right. And a big part of how it achieves this is through native dynamic resolution,
Which is?
handling images and videos of different sizes and frame rates without needing to resize them.
Got it.
And this allows it to, really learn scale information inherently.
So it's not losing any detail.
Exactly. It also has improved accuracy in detecting, pointing, and counting objects.
Okay, so it's getting really precise.
Very precise, and it's designed for comprehensive document parsing.
As we were talking about before.
Yes, being able to understand all sorts of different document formats.
So those are the highlights, the key takeaways.
Right, that's what makes Qwen 2.5-VL stand out.
Okay, so given all of that, I'm still curious about that sandwich analogy.
All right, I'll bring it back.
Okay, I'm intrigued.
So the bottom layer, the base of the sandwich, the foundation,
Uh-huh.
that's kind of where you start with all the intricate visual tasks.
Like being able to recognize the tiniest detail.
Yeah, exactly, that sort of thing.
Okay.
That's the foundation.
And then the top part.
And then the top is where it starts to get really interesting because that's where you have all the higher level reasoning tasks.
Oh, right.
You're combining different types of input like vision and language.
So it's not just seeing things, it's actually understanding them.
Exactly. Yeah.
What I think is really cool, and maybe this is getting a little bit ahead of ourselves, but just flipping through the report, one of the things that caught my eye is that it can handle images and videos of any size without distortion.
Right, right.
Which is something that, we always hear about, right? Having to resize and reformat things. This just takes it all.
It's native dynamic resolution. That's what they call it.
Native dynamic resolution.
Yeah, and it works for videos as well, like the frame rate.
Wow. Okay.
It's the idea that instead of having this fixed grid of pixels, it's sort of breaking the image or video down into these smaller patches. And then each patch can kind of have its own resolution. So depending on what's in that patch, it can have more detail if it needs to.
Okay, that's clever. So the techie in me is wondering about this, how does it handle the computational divides? Because, processing all that data must be a lot.
Right, it's a lot of data.
How do they even do it?
So that's where this idea of window attention comes in. It's almost like if you think about looking at a huge mural, you wouldn't try to take in the whole mural all at once.
Yeah.
Too much to process. What you would do is you would focus on a smaller window
Yeah.
and then kind of move your attention around. And that's what this model is doing. It's focusing on specific windows of the image or the videos.
Okay.
To kind of make it more efficient to process.
So instead of like reading the whole book, you're reading a chapter at a time.
Yeah, exactly. Something like that.
Oh, that makes sense. That makes a lot of sense. But what about understanding events in videos, especially when we're talking about long ones? How does it know what's happening when?
Right. That's a great question.
Yeah.
So they have this thing called, oh boy, multimodal rotary position embedding aligned to absolute time.
Okay, well, that's a mouthful.
It's a mouthful. But essentially what it's doing is it's allowing the model to understand not just that something's happening, but when it happened within the actual time of the video.
Oh, okay. So like knowing that no one baked a cake versus knowing they started baking at 2 p.m. and finished at 3:30 p.m.
Precisely.
Okay.
And that, might seem subtle, but it's actually really important because it allows you to start to reason about like, well, how complex was that cake?
Now that's interesting.
Like if you had a very short amount of time, it probably wasn't that complex, a cake. But if it took a lot of time, then it must have had many layers and, maybe some really intricate decorations.
So it's not just the actions, it's the context around the actions as well.
Exactly, exactly. And this becomes even more important when you're talking about like really long videos because you need to be able to keep track of what happened when and how that relates to what's happening now.
Okay, that's cool. And then there's this whole thing about pointing.
Oh, yeah.
It can point to things.
It can point to things.
What does that mean?
So if you think about like a typical object detection model, what they do is they draw a box around the object they've recognized.
Right.
Qwen2.5-VL can actually point to specific parts of the object.
Oh, wow.
It's almost like using a laser pointer.
Okay.
So if you asked it to find, the power button on your remote, it wouldn't just highlight the whole remote.
Yeah.
It would tell you where the button is.
Oh, so it's not just seeing, it's like it's actually understanding the structure of what it's seeing.
Exactly, yeah. It's getting a much deeper level of understanding.
That's impressive. Speaking of like details, the report also highlights how good it is at like parsing documents.
Yes.
It can handle different layouts, languages.
Yeah.
You can even, look at stuff like chemical formulas, musical scores.
Right.
Pretty wild. Does this mean I'll never have to manually enter data from a receipt again?
Laughs. I don't know about that.
Yeah, okay.
But I mean, it is really good at this
Yeah.
because it's been trained on this massive data set of documents in all sorts of different formats,
Right.
tables, charts, formulas. And so it's able to kind of take all of that and extract the information that you need regardless of the format.
So it's like it knows how to read a blueprint.
Kind of, yeah.
Okay. Now, what about this agent functionality?
Ooh, that's a good one.
It sounds very sci-fi.
It does.
Is this like having a tiny little AI assistant living in my phone?
Laughs. It's a kind of a step in that direction. What they're doing is they're training this model on data from all these different device platforms.
Yeah.
Smartphones, computers.
Right.
And so it's learning to understand how to interact with apps, how to understand what's on the screen.
Oh, wow.
It can recognize buttons. It can understand what the buttons do.
Okay, now that's just cool. But how do you even begin to train something this sophisticated? Like, how do they actually do it?
Well, they use a process called pre-training, and it has 3 main phases:
Okay.
visual, multimodal, and long context.
Okay. And each one kind of builds on the last.
Exactly, yeah. It's like you're gradually increasing the complexity of what the model can understand.
Okay.
And the amount of data they use for this is massive. Look, we're talking trillions of these things called tokens.
Trillions.
Yeah.
Okay.
It's mind-boggling.
So it's like you're teaching it the alphabet, and then you're teaching it to read a book, and then you're teaching it to understand the themes and the plot of the book.
Exactly, yeah. Like in the visual phase, it's learning to see and understand basic visual elements.
Okay.
And then in the multimodal phase, it's learning to connect those visuals with language.
Right?
So it's understanding the relationship between what it sees and what it reads. And then finally, in the long context phase, that's where it's learning to really understand those complex sequences of information, like, the flow of events in a video or the structure of a really long document.
Okay, that makes a lot of sense. But what about those really complex document layouts with charts and tables and text all mixed together? Like, how does it make sense of all that?
So for that, they've developed a specific format that they call the Qwen2.5-VL HTML format.
Okay.
And it's basically a way to represent all the different elements of a document text, images, tables, formulas, in a way that the model can easily understand.
So it's like giving it a map of the document so it knows where to find each piece of information.
Exactly, yeah.
That's clever. But, one thing I've learned about AI is that data quality is everything.
Oh, absolutely.
Garbage in, garbage out, right?
Right.
So how do they ensure that the data used to train Qwen2.5-VL is actually good data?
Yeah, it's really important. So they actually have a two-stage data filtering pipeline that uses both rules and models to try to weed out any problematic examples.
So like they have this whole team of super meticulous editors going through every single piece of data.
Yeah, pretty much. They're looking for things like repetitive patterns, incomplete responses, irrelevant data, anything that could negatively affect the model's learning. And they even have a special process for removing repetitive patterns in document and OCR data.
Okay, wow, that's intense.
Yeah.
So they're really making sure the model learns from the best examples.
Right.
Is there anything else they do to kind of improve its thinking ability?
Yeah, so they use this technique called rejection sampling.
Rejection sampling.
Yeah.
What is that?
So they basically use an intermediate version of Qwen2.5-VL
Okay.
to try and solve problems.
Okay.
But then they only keep the examples where it gets the answer right.
Oh, so they're only training it on the good stuff.
Exactly. So they're kind of like refining the model's thinking process.
Right.
By only keeping the instances where it reasons correctly.
Okay, so it's like you're giving it a puzzle and you only reward it when it figures out the solution.
Exactly, yeah.
Got it. Now, the report also compares Qwen2.5-VL to other leading models like GPT-4o and Claude 3.5 Sonnet and Intern VL 2.5. How does it stack up against the competition?
It's actually doing pretty well, especially in areas like document and diagram understanding.
Okay.
But it's important to remember that every model has its own strengths and weaknesses.
Yeah, of course.
Some might be better at certain types of visual reasoning, while others might be better at language generation. It really depends on what we're trying to do with it.
Right, right. Okay, well, this has been a fascinating dive into Qwen 2.5-VL already.
Yeah.
And I think we've covered a lot of ground. Maybe this is a good spot to kind of pause and take a breath.
That sounds good.
We can pick up where we left off in part 2.
Yeah, definitely. There's a lot more to explore.
There is. We haven't even gotten into the nitty-gritty benchmarks and how it actually performs.
Exactly. Yeah, that's going to be fun.
So join us next time for part 2, where we'll put Qwen 2.5-VL to the test.
It's going to be exciting.
We'll see how it measures up against the best of the best. See you there.
Welcome back. It's great to be continuing our deep dive into Qwen 2.5-VL.
Yeah, and I've got to say, my head's still spinning a little bit from last time.
A lot to process.
It is a lot to process, but, I'm eager to see how all that technical stuff we talked about, how it actually translates into, real-world performance.
Yeah, absolutely.
The report mentions some pretty impressive benchmarks.
Right.
Especially against some of the heavy hitters in the AI world right now.
It does.
So let's dig into that. What kind of benchmarks are we looking at here, and what are the key takeaways?
So, for this part of the dive, let's really focus on their kind of flagship model. They call it Qwen2.5-VL72B.
Okay, Qwen2.5-VL72B.
Yeah, so that's kind of like the top of the line version.
Okay.
And it's performing really well, especially when you compare it to things like GPT-4o and Claude 3.5 Sonnet.
Those are big names.
Yeah, absolutely. Those are the ones to beat.
Okay, so we're talking about a model that can, go toe-to-toe with the best of the best.
Yeah, yeah.
So what kind of tests, what kind of benchmarks are we looking at?
So some of the really challenging benchmarks are things like MMMU and MMMU Pro, and these are really trying to test the model's ability to do these really complex multimodal tasks where you're not just understanding text and images, you're also having to generate them.
Okay, so these are like the college level exams of the AI world.
Exactly, yeah.
The really hard stuff.
The tough stuff. And on these tests, Qwen2.5-VL72B is getting a score of 70.2 on MMMU and 51.1 on MMMU Pro, which is, to put that in perspective, GPT-4o getting around the same score on MMU Pro. So it's really up there with the very best.
Okay, so it's like a brainiac.
Yeah.
But it can also see.
Yeah, exactly.
Okay, but let's get a little bit more specific. How does it do on things like math problems? I feel like even for humans, that could be kind of a tricky area.
Yeah, for sure. And that's actually where it really shines. So on this benchmark called MathVisca, which tests the model's ability to solve math problems that are presented in a visual context, like diagrams and charts and things like that.
Okay.
It gets a score of 74.8. And that's actually beating the previous top score of 72.3.
Wow.
So it's not just crunching numbers, it's
Yeah.
actually understanding the visual representation of the problem.
So it's like it can look at a chart and then answer questions about it.
Exactly. Yeah. Yeah.
Okay. That's pretty wild. What about more like general knowledge questions, the kind of stuff you might get on like trivia night or something?
Right. So they tested it on a whole bunch of those benchmarks as well. Things like Bench, and there's actually a whole series of those, Star, Mirror Bench, and even some multilingual ones like QA.
Okay.
And in all of these benchmarks, it's consistently performing at or near the top. So it's really showing that it's, really good at understanding those general knowledge questions that are based on visual information.
That's impressive. Now, I have to admit, as we were talking about last time, one of the things that really caught my eye was that whole document parsing thing.
Yeah.
The idea of never having to manually enter data from a receipt again really spoke to my soul.
Laughs. It would be nice, wouldn't
It
it?
would be amazing. So how did it do on those benchmarks?
Really well.
Yeah.
So on a whole range of OCR-related benchmarks, things like AI 2D, Text VQA, Doc VQA, Chart QA, and, many more.
A lot of Q's
A
names.
lot of Q's and A's, but in all of them, it was really performing exceptionally well. So it's really good at, extracting that data from those complex documents.
Okay. That's great news. That's great news. Now I know a lot of AI models out there, they kind of struggle with like nuanced spatial understanding,
Yeah,
really grasping, the relationships between objects in an image.
right.
How does Qwen2.5-VL handle that?
So, that was actually one of the things that they really focused on with this model
Okay.
is what they call precise object grounding.
Okay.
So going beyond just saying, oh, there's a person in this image, it can actually tell you where that person is in the image.
So if there were like multiple people in the image, it could tell you exactly where each person was standing,
Exactly. Yeah.
not just that there are people.
Right.
Wow.
And they tested this on a bunch of benchmarks like RefCoco, ODNW, and even a benchmark that they created themselves specifically for point grounding. And it's really showing that it can understand those spatial relationships and can identify specific details within that visual scene.
That's impressive. Okay, so let's shift gears back to video for a second. We've talked about how it can handle, different frame rates and different lengths of video. But what about like actually understanding the content of a video?
Yeah.
Can it like answer questions about what's happening?
Right. So for that, they have a whole bunch of video understanding benchmarks like Video MME, Video MMMU, MMVU, MV Bench, and even some that are designed for really long videos like Long Video Bench and LV Bench.
And on those benchmarks, drum roll please, how did it do?
It did incredibly well. So on LV Bench, which focuses on those really long videos, it's significantly outperforming even things like GPT-4o.
Wow.
And remember, this is not just like watching a cat video. This is understanding complex narratives, complex events that unfold over potentially hours of footage.
That's really pushing the limits there. Okay, now what about that agent functionality that we talked about earlier?
Yeah.
The whole like interacting with devices, being able to, use a computer or a smartphone. How's that coming along?
So they've tested that on a number of benchmarks as well, including things like ScreenSpot, ScreenSpot Pro, Android Control, and even some real-world online platforms like Android World and OS World.
Okay, I'm on the edge of my seat. How did it do?
So on ScreenSpot Pro, which is, looking at high-resolution computer use, it's getting an accuracy of 43.6%.
Okay.
And that's actually a massive jump from their previous model, Qwen2.5-VL72B, which was only getting like 1.6% accuracy.
Wow. That's a huge improvement.
Yeah, and in these online evaluations, like on Android World and Mobile MiniWab ++O, it's actually outperforming all the other models that they tested. So it's really showing that it can actually function in those dynamic real-world environments.
It's like watching like an AI like live in the digital world.
Yeah, pretty much.
That's pretty wild. So if you can already do all this, what's next? Like where are the limitations? Where can it improve?
Well, as amazing as all this is, there's always room for improvement. One area where I think they could really focus on in future research is enhancing its ability to handle even more complex and nuanced visual reasoning tasks.
Like what? Give me an example.
Like, imagine a scenario where it needs to understand the emotional undertones of a scene in a movie.
Okay.
Not just recognizing the objects and the events, but actually being able to say, oh, this scene has a kind of, melancholy feel to it, or this scene is very suspenseful, that kind of thing.
So it's like going beyond the plot of the movie and understanding like the emotional subtext.
Exactly.
Okay.
That's really challenging because you have to be able to decipher, subtle facial expressions, body language.
It's a lot of human stuff.
Yeah, it's very human. And then another area where I think it could improve is in handling more abstract concepts and symbolism, especially in like visual art or literature.
So like being able to understand the deeper meaning behind a Picasso painting.
Exactly, yeah. Or a Shakespearean sonnet.
Okay, that's a tall order.
Yeah, that's really tough because you need a lot of that like human intuition and cultural context.
Yeah.
But who knows, maybe someday we'll have AI art critics or literary analysts.
Well, that would be something. Okay, so we've covered the highlights, the benchmarks, the potential for improvement. What's the overall takeaway here? What have we learned about Qwen2.5-VL?
I think the big takeaway is that it represents a really significant step forward in multimodal AI. And it's not just about incremental improvements.
Right?
It's about really laying the foundation for AI systems that can perceive and understand the world around them in all of its complexity.
So we're kind of seeing like a new generation of AI being born.
Exactly. Yeah.
One that can see and understand what it's seeing.
Yeah.
That's amazing. Okay, well, this has been quite a journey.
Yeah.
I think I've reached the limit of my processing power for today.
Laughs me too.
So should we pause here?
Let's pause here. Let's let everyone absorb this, and then we'll come back for part 3.
Yeah, and in part 3, we'll explore some of the like ethical implications and the potential societal impact of all of this.
Right, because it's not just about the technology itself.
Exactly. It's about how it fits into the world.
Absolutely.
Okay, so join us for part 3 where we'll tackle the big questions. See you there.
All right, so we're back for part 3 of our deep dive into Qwen2.5-VL.
Back for more.
And, in the previous parts, we really explored like the nuts and bolts of this model.
Like how it works, how it's trained.
Right.
We looked at the benchmarks. It's doing some pretty amazing stuff.
Really impressive.
But now I kind of want to shift gears a little bit and talk about the bigger picture.
Yeah.
Like, what's the potential impact of this kind of technology